Beryl, Beryl, Beryl is my school, best education reservoir for young learners just like me. Beryl,
Are you ready? Good morning, students. How are you? I know you must have enjoyed your Christmas and New Year very well, and I'm wishing all of you happy New Year. And it is good that we start really knowing the fact that you will have so a great task or a project ahead of you, which is the oncoming SS3 exams. I really want to take last of the future because of you, and that is why we are taking this opportunity to upload this video and to also teach you. Today I'm going to be teaching chemistry because I know most of my students are here to get acquainted or understand the different calculations involved in practical chemistry. And I'm going to show a table and then we'll do some of the calculations that are involved. Are you ready? Okay. Now, if we talk about chemistry or the experiments that are being conducted or exams set by WAEC or NECO exam bodies, I want you to understand that first of all, you must be accurate in every calculation, even in carrying out the experiment. Now, take for instance, you are doing a titrometry. The first thing you're supposed to know is that when those apparatus are set before you on your table, you have to rinse and burette the apparatus with the particular reagent you are going to use in them. And once that is done, you are supposed to follow the due processes involved in having accuracy. Now, take for instance, you are doing a titration, and in titration, maybe the apparatus has been used for maybe another reagent in time, and decide to pour in the reagent that was assigned for that experiment without rinsing or maybe washing it. It will affect the endpoint. And if you don't stick to instructions, take for instance, you are asked to drop 3 indicators or 3 drops of indicators, and you end up having 4 or 2 or 1. Your endpoint originally will not be the same with what is expected for that experiment. So note all of these hints because it will really help you. Follow instructions as they are outlined or stated in your question paper, and then don't do anything that will jeopardize your success in that exam. So, yes. Okay, today we'll be looking at titration. I know so many of you know how to carry out titration very well, but when it comes to the calculations involved in titration, it becomes very difficult to calculate. And that is why I will have to give a table on how titrations are carried out. First of all, you have to have readings. Now, in drawing your table, WAEC expects you. In drawing your table, WAEC expects you to do the needful, the necessary things. Take for instance, you can't start drawing the table without, first of all, stating the indicator you are using for the experiment. So the first thing is indicator used. Now the indicator you use for that experiment is going to be there on the table, and it's going to also be stated in your question paper. So you quickly uplift it from the question paper and write it there. For instance, you have different types of indicator that are normally used. We have methyl orange indicator, we have phenolphthalein indicator, we have methyl red, and so on and so forth. But any of the indicators that is going to be used will certainly be stated in the question. Now, take for instance, you are going to be titrating a weak acid versus a strong base. You are expected to use phenolphthalein indicator. But if you are going to be titrating a strong acid versus a weak base, you are going to be using methyl orange indicator. Now, if you're using a strong acid versus a strong base, or a weak acid, a strong acid versus a strong base, any indicator is suitable, whether it's phenolphthalein or methyl orange. You have to take note. But take for instance, the indicator used is methyl orange. You have to indicate it. The next thing is the volume of your pipette. Volume of pipette used. Volume of pipette used, the volumes of pipette varies. You can have, first of all, you have 20 cm cube, you have 25 cm cube. Now the one very hard is 25 cm cube. Let's assume you use 25 cm cube volume of pipette. Okay? Then these two information can carry one mark based on the marking scheme. The next thing you have to note is the table itself, which is you begin by writing the burette reading. Now in the burette reading you have rough in cm cube, please indicate in cm cube. Then you have this first titration in cm cube as well. You have the second in cm cube. If possible, the third also in cm cube. Okay? And you rule your line. The next thing is you bring in the final reading before the initial reading. So I know I'm not teaching novice because we have done this before. I'm only trying to refresh your memory. Now, when you start that titration, the volume of the acid using the burette, you can start from the 0.00 mark. Now, don't forget that when you are carrying out titration, your decimal point has to be to 2 decimal places. It is very, very important. It has to be to 2 decimal places. Else, you'll be losing marks according to the marking scheme. You'll be losing marks. So you take note. Then, let's assume, or let me take some reading from the textbook, and then we can go ahead to do the necessary calculations that are involved. Okay? You follow me as we hurriedly put on the table on the board. Now you discover that what is there on the board are to 2 decimal places. Are to 2 decimal places. The initial reading is from 00, and then the final readings for each of the titration you're going to carry out. Then the next thing is the volume of acid used. Volume of acid used. Now, volume of acid used is when you minus the initial from the final. You take away the initial from the final, you have the volume of acid used. For this is 23.00. This is 22.00, and then for this other one is 22.00, whereas this is 21.90. So you take notes. This is the table. Let's assume you carry out the experiment, you have this table. Now, if we are to analyze this table critically, we discover that sometimes when I do make provision for marks for accuracy, if a student doesn't have that mark, well, it depends on how you carry out your reading. It is noted that when you are doing titration, the last 2 readings must not be more than, the differences between the last 2 readings must not be more than 0 plus or minus 0.2. So if you check your readings and it is whether you are subtracting or you are adding and it is more than 0.2, you have to go back and check or even do the experiment again so that you won't lose marks for accuracy. Is that clear? Now, once you've had your table in this form, once the table is set after you've carried out the experiment, the next thing is to find the average title. To find the average title. And you find the average title, For every experiment you carry out, we don't include rough when the average titer. You don't include rough. So we have the first titration plus the second titration and the third titration, all summed up, divided by the numbers of titration you need. Okay, so here we have the first titration, which is 22.00 plus 22.00 plus 21.90. Now all divide by 3. And once that is done, you know fully well that the average titer also is the volume of acid. The average titer is also known as the volume of acid. So if you divide, you have, if you sum of these, you have 65.90 cm³ over 3, which is the same thing as 21.97 cm³. So this becomes the average titer, which is the volume of the acid, which is the volume of the acid. Take for instance, you are going to invoke the formula very soon, which is the volume of the acid. Now, apart from knowing this, which is primarily for every titration you do, you must know at least these steps, at least get to this level first, before you start battling with the calculations that are involved or added to such a question. Now, if you look at the question or the page where I listed these values, there are questions that have been asked. They say, first of all, you have to calculate the volume of the acid used, the molar mass and molar concentration of the acid, and then the volume of carbon dioxide produced at SGP. Now for this, sorry I didn't give you the question, but I'm just giving an overview of how to find or do calculation as it involves in titration. Okay, now in this question we're told that 5.83 grams of anhydrous sodium triisocarbonic were dissolved in water and made up to 500 cm³. Now out of the 500 cm³, 25 cm³ portion of the solution was titrated against the solution of tetrahydrous of the 6 acid using methyl orange as the indicator, and the results were obtained. Now you have seen the results on the board. We have been mandated to calculate the volume of the acid used, which we've already done. The volume of the acid used from is just minusing the initial from the final. You find the volume of acid quickly. Then the next thing is, after the volume of acid from the table, you have to find the average titer, which we have also done, 21.97 cm³. We have also to calculate the molar concentration and the mass concentration of the acid. The molar concentration and the mass concentration of the acid. So with this, I'm going to give other parameters quickly that will aid us to calculating those parameters that have been told. Okay. Now, in the question, we have been given that the reacting mass of the base, reacting mass of Na2CO3 equals to 5.83 grams. That's given in the question. Okay. Now from the question also, we know that the volume of the base is 25 cm³. Now if you convert this to cm³, we will have 0.25. Yes, you have 0.25. No, 0.025. Sorry, 0.025 dm³. Then we have also been given in the question, okay, the volume, the original volume is given in the question. Okay, we invoke that later, let me know you start to confuse you. And then we also given the molar volume of gases, giving a molar volume of gases at STP equals 22.4 dm³. And then what else? We're given, okay, the relative molecular mass. The relative molecular mass for hydrogen. Okay, now actually I need to bring the question up so that you can follow as I try to solve, yes, the question. Now if you look at, this is the question. 5.83 grams of sodium trioxide dissolved in water and made up to 5 cm³. 25 cm³ portion of the solution was titrated against a solution of tetraoxide acid H2SO4 using metal orange indicator as the results, and the results, below were obtained. I have already displayed a table showing the results, and we went further to calculating the average titer. The average titer which we have to be 21.97 cm³. Now, that's the average titer for that question. But the question says we should calculate the molar concentration of the acid we should calculate, okay, that's the first one. Then we just calculate the molar mass or mass concentration. Calculate a mass concentration, the mass concentration of the acid as well. And then the third thing we are going to be calculating is the volume of CO2, as the oxide, produced. Now, these are the three parameters I'm quickly going to show you how they can be calculated. But we can't do this without first of all stating the equation for the reaction. The equation for the reaction, I can state it here. Okay, let me bring it down. Is sodium triacylcarbonate 4 in aqueous state reacts with H2SO4 in aqueous state to produce sodium SO4 in aqueous state plus water H2O liquid state plus carbon 4 oxide CO2 gas in a gaseous state. Now this is the equation for the reaction. Why am I saying the equation for the reaction? Is because we will need some parameters using the equation for the reaction. Now take for instance what we all or you have been used to is the almighty formula which says that CaVa is equals to over CbVb is equals to Na over Nb. Now if I will recap, Ca simply means the concentration of the acid. Va is the volume of the acid which we calculated from the table. That automatically becomes Va. You see Va there. Then you have Cb is the concentration of the base. Vb is the volume of the base. Volume of the base is given in the question because the question says that 25 cm³ portion of the solution was titrated. That automatically depicts the volume of the base, which is the volume of the pipette you use in measuring the base into the conical flask. Then you have number of or mole of the acid over mole of the base. Now, mole of the acid and mole of the base are gotten from a balanced chemical equation. And that is why it then states the equation on the board. So we can choose the mole of the acid and mole of the base together. Now, if you look at this is the base, this is the acid. Now, the mole of the base is 1. The physical one is there. The mole of the acid is also 1. So in this case, Na is 1, Nb is 1, which we will not use it because it's just 1. Are you following? So based on this, we can now first of all look at the parameters that have been given in the question before knowing what to do. But having it at the back of our mind that we are calculating the molar concentration of the acid. Now, in calculating molar concentration of the acid, molar concentration of the acid is the same thing as Ca, which is in mole per dm cube. That is the molar concentration of the acid, Ca. Okay. Now, before we calculate molar concentration, let's look at the parameters that have been given in this question. If you look at the question, we told that 5.83 grams of Na2CO3 were dissolved in water and made up to 500 cm3. 25 cm portion of the solution was titrated again. Now, originally, the concentration of the base is not given. Now, if you have two unknown in a particular equation or formula, the equation is not solvable because there are two unknown. We are to find Ca, we are not given Cb. So how can you use this formula? Rather, you have to look for another method to find Cb before you can invoke this formula. This is where students usually make mistakes. They just go ahead and invoke this formula and start manipulation, which is very wrong. But if you know what you are given, certainly you will not make mistakes. So as it is now, we don't have the volume of the base, the concentration of the base. And since we don't have the concentration of the base, we will have to find it first. Now, how do you find the concentration of the base? If you go back to the question, you discover that you have been given the mass of the base that was dissolved to prepare the titration, and the volume has also been given. Knowing fully well, maybe I should rub up some parts of the board now that you have taken the question down so that we flow. Okay, so fully now we're looking at the molar concentration of the acid. But we can't calculate the molar concentration of the acid if we don't know the molar concentration of the base. And in calculating molar concentration, originally molar concentration is in mole per dm cube. So molar concentration can also be mole over volume. Now if you have mole over volume, you'll be having mole per dm cube as your answer, which is molar concentration. Now before we can find the mole for the base, which is B, we are given the reacting mass. Now if you look at that molar mass, so we have amount, which is in mole. In mole is the same thing as reacting mass over molar mass. Okay? Of Na2CO3. So we have to first of all find that before we can apply this formula. Okay, in finding that, we have that the reacting mass, we will have to calculate the molar mass. So molar mass of Na2CO3. Now, don't tell me you don't know how to calculate molar mass. At your level, you should be able to calculate molar mass conveniently. Good. Now, if you know that the relative atomic mass of sodium is 23. So we say, and you have two atoms of sodium there, it becomes 23 times 2 plus carbon is just one atom there, and its relative atomic mass of carbon is 12. Plus 12. Oxygen is 16. Relative atomic mass of oxygen is 16, and we have 3 atoms of oxygen, that would be 16 times 3. Now, if you multiply this out, you'll be having 106 grams per mole as the molar mass of sodium triosocarbonate 4. Is that clear? Then we can now move ahead to calculating. Okay, we have the reacting mass already stated in the question, which is 5.83 grams. So if we are going to apply this now, amount in mole will now be 5.83 grams over the molar mass, which is 106 grams per mole. So the gram cancels the gram, and then you have a value. If you divide that, you have a value which is 0.055 mole. Okay? Also in the question, you have been given the volume. So that 500 cm cube was dissolved. So 5.83 grams was dissolved in 500 cm cube, and 25 cm cube of that solution was used for this titration. So in order for us to find the volume, actual volume, we convert 5. So you say volume. You have volume of Na2CO3. You have 500 cm. We divide it by 1,000. We convert it to 10 cube. This cancels this. So you have 0.5 dm cube. So ordinarily, our CB will now be, since it's mole over volume, and we have mole to be 0.55 over the volume to be 0.5. Now from there, if you divide that, you have to be 0.11 mole dm. Now this is CB. Remember I told you earlier that if you have two unknown in that equation, you cannot solve it. Well, now we have found B. This is not what we are told to find at first. But because we need it, we need to go find it first before we can now proceed in the normal calculation. I don't know if you have, okay, you can quickly look at it briefly. Maybe when you resume, you can ask your question. Or in any way you can channel your questions to me, no problem. So now we know CB. So if I invoke that formula now, we can easily use it because we now know our CB. Though CB was not given, but the parameters for finding it were in the question. That is what we should take note of. Okay, without wasting time, let's go now to finding the first thing, which is the molar concentration of the acid. So the first thing we are asked to calculate I is molar concentration. Now, this is what we have to find. How do you find it? I said you use the formula now. CA over CB VB is equals to NA over NB. Now, we have gotten this. Of course, you saw the procedure we did. We used to finding this, so we don't have two unknown in this equation now. We can solve it. So we need CA. Now, if you're looking for a simple change of subject formula, first of all, you cross multiply. You have CA VA is equals to, NB is equals to CB VB NA. Now, since we are looking for CA is equals to CB VB NA over VA and B. Are you following? Now, from the parameters, we have CB, we have VB, we have NA. Okay? So our CB is given to be 0.11 mole DMQ. Mole per DMQ multiplied by our VB. VB is the volume of the base, which I told you is the volume of the pipette, which is 25 cm3. Now, if you convert that to DMQ, what do you have? Even if you still use it in cm3, they will cancel out. So let's say we just use cm3 times the number of acid. You know, it was 1. We had to do that earlier. Then VB is the volume of the acid, that is the average titer we had earlier, which was 21.97 cm3. Now the cm3 will go with the cm3. Except we want to convert to DMQ, convert to DMQ, but that will waste your time. Times 1. Okay? Now if you multiply this out, you have, sorry, I don't have a calculator, okay? You have an answer, which is 0.125 mole per DMQ. Are you following? So that becomes the concentration of the acid. So we couldn't use this formula at first, except we needed to find CB. Now, having found CB, we were able to invoke it and use it to square it. So I don't want you to make mistakes. Take, for instance, you're writing an exam and you come across the same problem. Just follow the example I have used. First of all, I know the reactive mass in the question was given. I could find the molar mass. Then, you know, the reactive mass over molar mass will give us the amount in mole. When you convert the volume from cm3 to DMQ, you have the volume in DMQ. Divide the mole over with the volume, you have mole per DMQ, which is the concentration of it. And from there, you can find CA. I know you've gotten this, and because it's very simple, we're going to end the class here because we may not have time to continue with it. So if you have any questions, you should be maybe in our next class we'll finish up by calculating the concentration in gram per DMQ, and then also the volume of carbon 4 oxide produced during this reaction. So have a nice time. See you some other time.